Unit 1, Lesson 2, Prime Factors. Before we start, we need to know two definitions, prime number and composite number, and what the difference between both. A prime number has exactly two factors, one and itself. Factors means that when you take the number and you find this factor, the result of the division by this factor is gonna be a whole number, not a decimal. So I want to give you an example. If I have 10, let's say I have 10. When I divide the 10 by 2, the result is 5. As you can see, 5 is a whole number. That means this 2, it's a factor of 10. So this is the meaning of factor. So again, I'm going to remove this and we're going to go back to our definition. A prime number has exactly two factors, one and itself. So let's start with number 2. I need to know all the factors of 2. Can I divide 2 by 1? For sure, 2 divided by 1 equal 2. Can you see this is a whole number? That means 1 is a factor of 2. Next, can I divide 2 by number 2? Yes, 2 divided by 2, it's 1. Can you see 1? It's a whole number. That means 2, it's a factor. When you have something like that the 1 and the number by itself, which is in our case 2, are the only two factors, in this case we call this number as a prime number. That means 2, it's a prime number. Let's start with another number. Let's see number 3. If I divide number 3, can I divide by 1? Yes, 3. 3 is whole number. That means 1 is a factor of 3. 3. Can I divide it by 2? No, it's gonna give me what? It's gonna give me 1.5. It's not a whole number. That means I have to go for the next one, 3. Can I divide 3 by 3? Yes, 1. 1 is whole number. That means 3, it's a factor. So that means for the case of number 3, I have 1 is a factor and the number by itself, which is 3, is also a factor. That means 3, it's a prime number. What about 4? Can I divide 4 by 1? For sure, I will get 4, which is whole number. That means 1 is a factor. Can I divide 4 by 2? Yes, 4 by 2 equal 2. Whole number, that means 2 is a factor. Can I divide 4 by 3? No, it's gonna give me 1 point something, so it's not a whole number. Can I divide 4 by 4? Yes, it's gonna give me 1, which is whole number. That means 4 is a factor. As you can see, this case is different from the definition of the prime number. Why? It has how many factors? It has 1, 2, and 4. Can you see here? It's saying has exactly two factors, 1 and itself. In this case, yes, it has 1. Yes, it has itself, which is 4. But additional to that, there is number 2 is additional. In this case, we cannot say that 4 is a prime number. 4 belong to the other case, which is composite number. So as you can see, the composite number has more than two factors. Here we have 1, 2, and 3 factors. That means 4 is a composite number. Can we find any composite number? Yes, another thing, it's 6. I can divide 6 by 1 equals 6. I can divide 6 by 2 equals 3. I can divide 6 by 3 equal 2. Can I divide 6 by 4 to get a complete number? No. 5? No. 6? Yes. 1. So how many factors do I have? As you can see, I have 4 factors. That means more. That means 4 and 6 are example of a composite number. This is the difference between prime number and composite number. I hope you understood this part. Let's move to another example. find the factors of 84. As you can see, 84, it's large number. How we can find the factors? I like to have this strategy to get the number and to create a line and after that I can say, okay, let's divide 84 by the smallest prime number. We are not going to use composite number, prime number. So the smallest one, someone can tell me 1. No, 1 in this case, no, because it's going to be a loop. So we go to the next one, which is 2. 84 divided by 2. 8 divided by 2 is 4. 4 divided by 2 is 2. That means 42. Can I divide 42 by the same prime number 2? Yes. 4 divided by 2 is 2. 2 divided by 2 is 1. Can I divide by 2? No. So let's go to the next prime number. The next prime number is 3. Can I divide 21 by 3? Yes, it's 7. Excellent. I repeat again. Can I divide 7 by 2, the smallest prime number? No. By 3? No. By 4? No. 4 actually I cannot include it because it's composite. By 5? No. By 6 I cannot, it's composite number. Then I don't have a choice. 7 is a prime number till I get 1. 1 is the last thing, so that means all the prime factor of 84 is 2, 2, 3, and 7. And if you want to test if it's correct or not, say, is 84 equal to the product of these factors? We will see now. 2 times 2, 4. 4 times 3, 12. 12 times 7, it's 84. So as you can see, the product of the factors are the number. It gives you the number equal to the number. So that means my work is correct. So as you can see, the factors here of 84, the prime factors I mean, are 2, 2, 3, 4. Next, prime factorization is a product of prime factors. So if I have the 84 from previous, we said equal to 2 times 2 times 3 times 7. This is what we found from here. 2, 2, 3, 7. This is the prime factors. The product of the prime factors, we call it prime factorization. That means this is a prime factorization. Now I have some students, they do what? Instead of saying that, they say, okay, why we write it this way? Why we don't write it 84 equal to 4 times 3 times 7? This is wrong. Can someone tell me why? Why? Because 4, it's not a prime number, it's composite number. And here, if you read the definition of prime factorization, is a product of prime. That's why I underline prime factors. And sometimes some students, they like to do it this way. 84 equal 2 square, because 2 times 2, that means 2 square, times 3 times 7. This is correct. So this one is correct, this one is correct, this one is wrong because 4, it's not a prime number. Question, find the prime factorization of 200. Let's see this. Again, we said we're going to write the number. We're going to create a line. And I'm going to say, let's continue. 200. Can I divide 200 by 2, the smallest prime number? Yes, it means 100. Divided by 2, yes, it's 50. Can I divide by 2? Yes, 25. Can I divide by 2? No. By 3? No. 4 I cannot because it's composite number. By 5? Yes. Here 2? No. 3? No. 4 I cannot. 5? Yes, it's gonna give me 1, the last number. That means the prime factorization of 200 equals the product of the prime factors. So 2 times 2 times 2 times 5 times 5. Another student can write the prime factorization at 2 exponent 3 times 5 exponent 2. Can someone write 2 times 2 times 2, that means 8. 8 times 5 times 5? No, 8 it's not a prime number. Can someone say 8 times 25? No, 25 it's not a prime factor. So be careful when you are writing the prime factorization. Next, we have a question here. I need that you understand the difference between this question. Find the prime common factors of 18 and 24. Find the composite common factors of 18 and 24. Find all the common factors of 18 and 24. Each question is different than the other. Where are the keys word here? The first one, the word prime, be careful. The second one, composite. The third one, all. So they are different. So find the prime common factors. Common means that it exists in both numbers. So let's do it. I have 18 and I have 24. Let's check all the prime factors in each one. So for 18 and for 24. So in 18, can I divide 18 by 2? Yes, 9. Can I divide by 2? No. So by 3, yes, 3. 2, no. 3, yes, 1. 24, can I divide by 2? Yes, 12. Can I divide by 2? Yes, 6. Can I divide by 2? Yes, 3. Can I divide by 2? No. By 3, yes, 1. So these are the prime factor of 18. These are the prime factors of 24. Find the prime, they are prime, so this is good, common factors of 18 and 24. So I'm going to come with another color and we say I'm going to circle the common. 2 exists in both, the 2 is common. There is no other 2, there is no other 2, so let's jump to 3. I have 3 here and I have 3 here. Done. So 2 and 3 are the prime common factors of 18 and 24. So the answer of this one is 2 and 3. They are the prime common factors of 18 and 24. Now, if we say find the composite common factors of 18 and 24, the composite, it's right away the multiplication of 2 and 3, 6. 6 is composite common factor for 18 and 24. You want to test yourself? Say, can I divide 18 by 6? Yes. Can I divide 24 by 6? Yes. So this is the answer. And this is a difference between the prime and the composite. When it's saying all, you have all the answers. So 2 and 3 and 6. This is the answer for the third one when it's saying all common factors of 18 and 24. Excellent. Now we go to another type of question. Find the first 3 common multiples of 18 and 24. So now be careful, multiples, it's not factors, it's multiple, it's totally different. Note, the first common multiple is called the lowest common multiple, LCM. So let's understand first what we are doing, and after that we're gonna answer the question. So we saw at the beginning the factors, that the number that you can divide any number by this factor to get a whole number. What the meaning of multiple? Let's check the multiples of 18 as an example, and we will understand what the meaning of multiple. Usually the multiple of 18, there is many ways to do it. There is a kind that we are saying the multiples of 18 is, first thing, as you know, it starts with 18, comma, and after that I add another 18. So 18 and 18, 36. Someone will tell me, what are you doing? I can start with the first number 18 and I add 18 each time. So after that I have another 18 to get the third number, which in this case is gonna be 54. This is one case. Or some students, they think with this way: 18 equal 18 times 1, 18, 18 times 2, 36, 18 times 3, 54, and so on. This is how we can get the multiple of 18. And the 24, the same thing. We start with the first number 24 again, and we jump every 24. So in this case it's gonna be 48. Or there is some student, they're gonna say 24 times 1, 24, 24 times 2, 48, and so on. So this is how we can find the multiple. But the question is saying the first 3 common multiple. Wow, with large number like that we need a calculator maybe. So that's why I will show you another way to find the first common multiple, which means we call it here the lowest common multiple. And with this way, if you reach the lowest common multiple, this is going to be your first one. Then after that it's easy to find the second and the third. How we will do that, I will show you right now. So let me remove this one, and I will explain to you how to find the lowest common multiple of 18 and 24. Again, 18, we will do the same thing. We will find the prime factors of 18, and we'll say 18 I can divide it by 2. It's 9. Can I divide 9 by 2? No, so it's 3. Gonna give me 3, 3, and 1. And the second one for 24, I will find all the prime factors of 24. 24, can I divide by 2? Yes, it's 12. Divide by 2, yes, 6. By 2, yes, 3. Then 3 and 1. The best way to find the lowest common multiple or the first common multiple is to say, if I have 18 equal to 2 times 3 times 3. If you remember, this is a prime factorization. Let's put the 24 under the 18 and create column of the same number. Do I have 2? Yes, I can add 2 under 2. There is 2 other 2, but here we have 3, so I can go far a little bit and create a new columns for these 2. Then don't forget there is a 3, so I can put 3 with the 3. So as you can see, 2, 2, 2, 3 2's and 3, 3 2's and 3, and the first one 2 and 2 3's. And if you see here, I create some columns of the same number, and if it's empty, no problem, it's still a column. So I can say the lowest common multiple equal to 2 times 3 times 3 times 2 times 2. So 2 times 3, 6. 2 times 3, 6. 6 times 6, 36. 36 times 2, 72. So 72 is my first common factor. A common multiple, I'm sorry, not factors, multiple we are working with. So now, how can I find the next after that? To find the second and the third, it's very easy. All we have to do is to take the first one and time it by 2 and by 3. So if we say the first common multiple equal 72, the second common multiple equal 72 times 2. So as soon as we found the first one, it's easy to find the rest. So in this case, 72 times 2 equal 144. 2 times 2 equal 4, 2 times 7 equal 14. Then if I need the third common multiple, I take the 72 again times 3. So 216. This kind of problem is very, very dangerous. Why? Because if from the beginning you found the wrong first common multiple, the second and the third will be wrong too. So this is how we can answer the different question, and this is the difference between the multiples and the factors. I hope you understood this lesson, and next lesson is going to be unit 1 lesson 3. Thank you.